Alright, so we're going to start graphing in standard form, and this is very similar to slope-intercept form. It's got an x, it's got a y. The only problem is this is not in slope-intercept form. You know, slope-intercept form usually looks like this, where the y is all by itself, and you've got your slope and your y-intercept on the other side. Well, if it's in standard form, I have to get it into slope-intercept form. So if I'm in standard form like this, I want to rearrange it so that it actually looks like something that I can put on a graph. To graph something, I need the slope, I need the y-intercept. If it's in standard form, I just have to get it in slope-intercept, and all I have to do is essentially just solve for y. Okay, I want y to be by itself. And in this case, in this first example, and it'll be a little different than this every now and then, but you'll notice the 4x is over here. I need my, whatever's next to x is my slope. It needs to be on the other side. So I'm going to treat this like an equation, and I'm going to get this 4x to the other side. Well, it's a positive 4x. I'm going to treat this like an equation now, where I'm solving for y. So I would subtract 4x from both sides to get rid of this. And now what we have left over is y equals, we got the negative 4x over here where we want it, now the slope, and that plus 4 is just going to become my y-intercept. Now this is in standard form. So I had to get this 4x to the other side by subtracting it, and I'm basically just solving for y. Now I know that y equals negative 4x plus 4, and that is slope-intercept form. Now I know where to start. I've got that positive 4. That's where I'm going to start this graph. And this negative 4x, that's my slope. And you remember, if it's a slope, I can always put a 1 under it if it's a whole number. So my slope is negative 4, or negative 4 over 1. That means I'm going to go down 4, right 1, and put my first dot. And that's how I would graph this line. So my line is just going to go between those 2 points. This is a negative slope, so my graph will look like this. Okay, so before I can graph it though, if it's in standard form, and that's one way to do it. And I want to show you a shortcut, another way you can do this, okay, that works most of the time and it's much quicker. But this is how I would do it. I would put this, go from standard form to slope-intercept, and then just put it on a graph. So we're just solving for y. Now there's a shortcut way to do this. All right, and if I had, let's say if I had this, I'll bring this up here to the top. It's a little shape right here. Okay, I'm going to use this to kind of take a shortcut. All right, now you'll notice on this graph that it has an x-intercept and it has a y-intercept. There's an easier way to find this. Instead of putting this in standard form, and this is kind of a way I used to always do this, you'll notice that if I just cover this up, let's say I take the x term, whatever that is, if I just cover that up, cover up the term that's in front of the y, if y is by itself, it gives me the y-intercept. Here it tells me that y equals 4. Well, that's the y-intercept. Okay, and now I'm going to do the exact opposite of that, and I'm going to go, and let's say I covered up the y term. If I cover that up, it tells me that 4x equals 4. Well, I can use that to find the x-intercept. If I were to divide by 4 on both sides and solve for x, x equals 1. Okay, so there's a shortcut here, and this is the graph. I only need 2 points to make this line, so I could do it that way, and it won't always work out perfectly like that, but it will most of the time. I can just cover up the y, figure out the y-intercept, cover up the x, figure out the y-intercept. It won't always work out where it gives you whole numbers, but most of the time I can use this to at least kind of figure out what the graph's going to look like. Here I know the x and y-intercept, I can make that line. Okay, now let's look at another example here. All right, now here we have another example of standard form. So I've got to get this into slope-intercept form. I have to solve for y. I want this y to be the only thing left on this side of the equation, on the left. I've got to move everything else to the other side. First thing I'm going to do is get rid of this positive 2x by subtracting 2x from both sides. Now remember, I can't subtract 12 minus 2x and get a number. Those are not like terms. So they cancel on this side, and I'm left with negative 3y equals negative 2x. I'm subtracting that 2x. And I still have the positive 12. I still have that y-intercept over there. But now I have to get rid of this negative 3 that's still in front of the y, because like I said, I want y by itself. So I will get rid of this negative 3 by dividing everything on the other side of this equation by negative 3. Okay, so I'm dividing everything by negative 3 on the left, everything on the right, and that'll give me a fraction for my slope, negative 2/3 x, because it's negative 2 divided by negative 3. That's actually going to give me a positive. Two negatives divide to give me positive 2/3 x. And then I've got 12 divided by negative 3. That's going to give me negative 4. And that's actually my y-intercept. So now I have done what I was trying to do. I have solved this thing for y. Y is now the only thing on the left. And I could graph this just like we normally would. Negative 4 is going to end up being somewhere down here at the bottom. Let me see if I can slide this up a little bit. All right, there we go. All right, so my negative 4, that's my y-intercept. That's where I'm going to start, according to this new equation we just came up with. And my slope was to go up to right 3. So I go up to right 3, 1, 2, 3. And that's going to be the line that I have. And I can continue doing that as long as I need to do it. But I only need 2 points to make a line. All right, so now I know what this graph looks like. I just had to put it in standard form. Okay, so that gave me the y-intercept, gave me the x-intercept, and you'll notice when you look at this graph, I have a y-intercept, I have an x-intercept, so there is a shortcut that I could use to get that, all right? And you don't have to do it this way. You can do it either way. You can convert it to standard form every time, or into slope-intercept every time if you choose to. It doesn't really matter. You can get the same thing. But I think it helps to know the shortcuts here. So what I could do with this, instead of doing what we just did, I could actually just cover up one of those terms. Let's say I covered up, get rid of this graph here. If I took this little square and I covered up one of these terms, I covered up 2x. Look at what I have when I cover up that x term right there. Okay, I have negative 3y equals 12. I can easily solve that, divide both sides by negative 3. That's going to give me y equals negative 4. That's my y-intercept. So, and I only need 2 points when I'm making a graph, so there's my y-intercept. Alright, so instead of converting this to standard form, now watch. I can take this little square here and I can move it to the other side. I can cover up the y value. So I can take this, move it over, and that gives me 2x equals 12. Well, to solve for x, just divide by 2. X equals 6. That's my x-intercept. I only need 2 points to make a line. So I just, by kind of blocking one of those terms out, I've created the line. It's the same thing as converting it to standard form. Now sometimes your x-intercept or your y-intercept might be a fraction, like it may cross somewhere over here, and in that case you just kind of have to estimate. But that's what the graph of that line is going to look like. Alright, so this is number 1 from the homework, and they give you the equation in standard form and they want you to match it to the equation in slope-intercept form. So I'm still going to do the same thing no matter what the question is asking. I'm still just putting this in slope-intercept. So I got to get rid of this 3x by subtracting it from both sides, because I want this to say y equals something. I'm trying to isolate y. I want to get y all by itself. So I'd subtract 3x from both sides, and that's going to leave me with negative 2y equals negative 3x plus 12. So I just move that negative, or that 3x to the other side by subtracting. Now I have to get rid of the negative 2 because I want this y to be the only thing over here. So I have to divide by negative 2 on every single term on both sides of the equation. And that's going to get rid of this. Now it's like I want it to look. Y equals two negatives, negative 3 over negative 2 divide to give me positives, and then 12 divided by negative 2 is negative 6. That is now in slope-intercept form. I just had to move the x to the other side, and then I had to divide by what was in front of y. Okay, so positive 3 over 2x minus 6.